Alright, this is video 2 of tutorial 1 of scalar fields and quadric surfaces. That one got cut, I don't know for what good reason, I don't know. Okay, so we're doing part B of the tutorial, and then we did all the steps, and then it got cut when I was just after this step here. Okay, now and then I'm advising you to watch it first and then come back to this one, because you might not understand what exactly I'm talking about. Okay, and then okay, from this thing here we did all these things like I said. Now we're letting z to be equal to d, and then when we let z is equal to d, you're gonna have something like x squared plus 2y squared is equals to 4 plus 3d squared. Okay, and then we see that these surfaces, these sections, ellipses 4 plus 3d squared greater than 0. Okay, so like you can see that like this thing can be 0, like it can never be negative. Actually, can never be negative. If d is negative, it's going to make, like, we're squaring a negative, so it's going to be a positive. So we have ellipses, and then the whole surface is called elliptic hyperboloid. Okay, hyperboloid. Okay, now with elliptic hyperboloid we have two kinds. Like we have hyperboloid of one sheet and a hyperboloid of two sheet. And then I'm gonna do so this one has to be either of the two. Okay, now the way in which we're gonna determine that is that we're gonna find what happens when d is equal to 0, like at the axis. So if we are to do that, we're gonna, when d is equal to 0, our thing is gonna be x squared plus 2y squared is equals to 4, and then still we get an ellipse, meaning that our thing goes from it rises from above the axis, whichever axis. Okay, we're looking at xy axis, so it moves from the top of the axis, of the x-axis, to the bottom of the axis, and then it doesn't get cut anywhere. So we say that this hyperboloid of one sheet, and then it's actually something like something like this, like those towers in Soweto. Yeah, must have seen them, something like this. Okay, so here they form ellipses, and then something like that. Okay, now hyperboloid of one sheet. So that was it for part B of the tutorial, and then we're going to part C. Okay, C. Okay, and then on C we have something like x squared plus 2y squared. Oh god, x squared plus 2y squared minus 3z squared is equals to minus 4. Okay, gonna do the same thing. Let x is equals to c, and then when we do that, we have 2y squared minus 3z squared is equals to minus 4 minus c squared. Okay, and then if you were to check this out, like this side here, it shows that it's a hyperbola. So if c is far greater than 4, this thing here is going to be a negative, and then that means we can divide throughout by a negative. So if we divide throughout by a negative, 2 is gonna be negative, and then z is gonna be positive. So this thing is gonna be, they're gonna be the what? The sections are gonna be hyperbolas for all c negative, c positive. They're gonna be hyperbolas, and then you're gonna let y is equals to k, and then when we do that, we get x squared minus 3z squared is equals to minus 4 minus 2k squared. And then check that this thing is the same as that one, so you have hyperbolas for all k. Okay, and then the last one, the last section that you need to determine is the xy section, and then we do that by letting z is equals to a constant d. Okay, and then when you do that, we get x squared plus 2y squared is equals to minus 4 plus 3d squared. Okay, and then looking at this, it's an ellipse. We need to determine the relationship, like the behavior at the origin. Okay, now what we're gonna do, it's an ellipse, so you get ellipses 4 minus 4 plus 3d squared being greater than 0. So this thing has to be greater than 0. So that means that d squared is going to be greater than 4/3. Okay. Now we have this here. Now we need, because it's an ellipse, we need to determine the behavior at when d is equals to 0. Okay. So when d is equals to 0, we have something like x squared plus 2y squared is equals to minus 4. And then this thing is impossible. It is impossible because there's no number such that you're gonna square it and then you get a negative number. So that means that our section does not exist at the origin. Okay, so we do not have ellipses at the origin. That's what it means. Okay, so basically, like, it's something like it's likely to be something like this, and then like that. We do not have ellipses. Like, nothing exists here. This section here, nothing exists there. So we're gonna say that this is because we're determining at d is equal to 0. So, oh, by the way, I skipped one step, but that one is where you have to say that this thing here is an elliptic hyperboloid, and then you need to determine whether this is of 2 sheets or a single sheet. And then from what I explained here, we get that this hyperbola of 2 sheets. Okay, now that was part C for you, and then I'm gonna do D. I think that will be enough so that you can do the rest of what will be remaining. Okay, now for part D, we have something like part D is like x squared plus 2y squared minus 3z squared is equals to 0. Okay, the procedure is the same. We let everything be 0 and then determine the section we get for that. Okay, so we're gonna let x is equals to a constant c, and then when we let x equals to a constant c, we get 2y squared 2y squared minus 3z squared is equals to minus c squared. Okay, so note that this thing for sorry about that, like I was saying, we have something like 2y squared minus 3z squared is equals to minus c squared, and these things here are hyperbolas. These are hyperbolas for all c. Okay, now we're gonna let y equals the constant k, and then when we do that, we get x squared minus 3z squared is equals to minus 2k squared, and then still these are hyperbolas for all k. Okay, and then we're gonna let z is equals to d, a constant t. Okay, d has to be a constant, and then when we do that, we get x squared plus 2y squared is equals to 3d squared. Okay, now from this we get ellipses when 3d squared is greater than 0. Okay, so that definitely tell you that d squared gonna be greater than 0. Okay, now because it's an ellipse, we want to determine what happens when d is 0. So when d is 0, we get something like x squared plus 2y squared is equals to 0. Okay, the only case in which this thing can happen is when x, y, and z, where z is equals to d, are equals to 0, 0, 0. Okay, so that means that these things, they are at the origin. So they are at the origin, and therefore, because they meet at the origin, we say that this is an elliptic cone. Okay, now I'm gonna advise you to go to the last I don't know how many there are, but I'm advising you to go do those, and then if you're stuck, send me an email. I hope you still have my email, lastiles@gmail.com. Send me an email, and then I'll see how I can help you. Thank you for watching.